Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you can tell by the title and the thumbnail, we will be talking about the quickly growing potential for a monster-sized winter storm. Now, this is truly going to be a potentially unprecedented event. We haven't had a large-scale system like this in December, followed by what could be a potentially historic, unprecedented cold Arctic outbreak that we haven't seen in December in years, essentially decades. Some people are comparing this to what we saw in the early 1980s. 1983, I believe, was a really cold outbreak in December. You may have seen articles. I saw one today finally noticing what we've been talking about on here for weeks. CNN talking about the polar vortex and a sudden stratospheric warming that might be unleashing cold. Yeah, might be. That you could have been saying that a few weeks ago. If you've been watching my channel, you know that the cold is coming. Nothing has changed. In fact, I'll show you some of the long-range models at the very end of this video. The signals have intensified for more cold, more snow. This is just one of many systems that the models are looking to forecast, and this one alone is going to be a headache. So I want to begin with the European AI model. Yes, they have an AI model now. It's been there for a little bit. It hasn't been really tested through a winter season, at least under my scrutiny, which is obviously the best in the world. That's a joke. That's a joke. But this model, interestingly enough, it doesn't unfortunately have the rain-snow distinction, but there are a few ways you could tell if there is snow on the map, even though it shows green. But it has picked up a signal that some of the models now are doing, actually both of them, the GFS and European. So I want to go over this one first because it's almost been kind of like a trendsetter in some sort of the way. So this is the most recent model run I have of it. It's also a really nice one because it comes out every 6 hours to 360 hours. And if you are part of the weather community, you know that, and you use the weather models, you know that the European operational model only comes out to 360 hours every 12 hours. So it's kind of a nice view. And do note that right now we are dealing with a pretty rainy system, completely different to what we will be seeing come late Thanksgiving into December. Almost no cold air, so this is just going to move out. I don't really want to focus too much on it as there's just so much to talk about, and I'm going to try squeezing this into a 12-minute, 13-minute video. The first system that we are going to be having is the one that I have been addressing, though it's not the monster. This is a system that the models have been struggling with in its own way, the positioning of it. It's essentially a piece of southern sluggish moisture that is going to be moving very slowly towards the north, and then a piece that, as last time I was calling more elegant, but someone in the comment section told me what I should call it instead, or not what I should, but what I wanted to call it. It has more of a closed circulation. It is more defined. It has stronger winds with it. It's also on the front of cold air, so it could develop into a nicer system given moisture. But the models have been back and forth battling whether or not these two will connect. And if they do, where? How far north? How far south? The further north you go, you know, cities like Regina, maybe Brandon, Winnipeg could be under for some snow, though lately the models have been shifting this a little further south. As I put this forward, do note that this is a southern scenario, or more southern scenario, and you can see that the AI model shows potentially some pretty nasty snow and winds across Minnesota into the Wednesday of Thanksgiving. So this system would be very disruptive. Thankfully, it's not the monster we're talking about, but again, any weather on Wednesday prior to Thanksgiving is going to be very disruptive. And I want to say, by the way, that the timestamp of where this is all occurring, or I should say when, is at the very top, 114 hours out, November 26th. Sometimes I forget to say and mention when this is occurring because there's so much to talk about. But this is Wednesday, November 26th, and you can see it actually has some pretty strong winds. There could be some blowing snow, and you could tell that this would be snow because you see this 540 line. I don't know how hard or easy it is to see, but it starts way back over here. It's a blue line, and that is the freezing line. So anywhere north of here should be some form of rains or freezing rain, sleet, snow. The further back you get, it's going to be snow because if you look at the temperature profilings, the 2-meter temperature shaded, you can see it's in the 20s and 30s. So that would be falling mainly as snow, but that again is not our main system. I'll show you what the GFS shows about this in just a little bit. But behind that we get our first wave of cold air following what has been an incredibly warm fall. Outside of that little cool down we had in November, and portions of the mid-Atlantic and southeast have been cooler, but most of the country very warm. And now this model shows a potential clipper system into the first part of the weekend across the Midwest. That is something new that the model has been showing. But regarding this system, what it's been doing doing is showing a massive slug of moisture behind this much larger cool down, not just a small one like we will be seeing after Thanksgiving. And you can see it starts beginning to become more and more positively tilted. If you learned about slope in the school, this is a negative slope, this is a positive slope. So it becomes more positively sloped as some of that cold air and that really, really warm air that's pushing up towards the north begins tilting it up. So what this allows is essentially a storm system to develop with a lot of heavy snow, because there's so much precipitation for a large period of time, a long period of time, and a large period of the large section of the country, and that will allow for a very heavy snowfall rates without even the system forming it. Now notice, this model takes this potential snow line all the way down into New Mexico, Texas, Oklahoma. It could be snowing all the way from the eastern shore of Canada, according to here, all the way down to potentially the Pacific Ocean there. Well, maybe not snowing, but the snow would end just a few hundred miles shy of that. So an incredibly monster-sized system, and all the models are showing this. And more specifically, what this model picked up on earlier than many of the other models is it kind of showed it in two parts. So first it showed this massive slug of moisture becoming slowly positively tilted as it wraps into that cold air, but then it shows a second surge of moisture later on, which you could see potentially impacting areas a little further east with some snow. And right there, you can see it developed right there, a area of circulation. So that is, it may seem very subtle, but that is something, especially in a model run like this that's so far out with using such large, broad areas of precipitation. If it shows a signal like that consistently, it's something to take note of. So now I want to take a look at the European operational. So this is not the same model. It may sound like it's similar. The other one was a European AI one, still kind of an experimental one run by NOAA. This is the operational one that is kind of used more for forecasting. But as we've seen, the other one can give us some interesting insights. So this one I take more seriously. And you can see that right now we are at hour 3, so current time. Again, no sign of a monster system. In fact, it's very balmy. So a lot of people may be watching this video and being like, what is this guy talking about? It's like 50 degrees here. And I know this weekend will be very warm, but you could take it as a calm before the storm. And you could see that on Monday, Tuesday, we still don't see anything. And this is the beginnings of that first system, not the monster one, but the one that could potentially bring snow into northern areas of the, I guess, viewing area. So Minnesota, Wisconsin, southern Canada, depending on the model run. And do note that this model is no different. It kind of struggles phasing these two systems together. Quite a bit of moisture towards the south, maybe some bit of a severe weather potential. Again, it comes during an unfortunate timing of right around the Thanksgiving travel. It doesn't look like a monster system. It just looks like a system. So that's, I guess, the good news. And you can see the European operational takes this a little further north and brings the snow not into Wisconsin, central Wisconsin or the UP, but into Minnesota, Ontario, portions of Manitoba there. And it doesn't have as defined of a circulation until it gets further into central Ontario and into Canada. Still, the cold air follows it. And just because it doesn't necessarily agree, I guess, exactly with the AI model run with this system, it does a pretty good job of showing the next system in a similar fashion. Note, there's that potential clipper that the AI model showed into the Midwest around the early part of the weekend. So that's something to watch for if you live across Illinois, Indiana, Ohio. Again, it's far out, so it'll probably change, but it's a signal that we've been picking up on now for a little bit. And there is that slug of moisture from the west that this thing already is a lot more developed and a little further north than what the AI one showed. Note, incredible southerly flow. I mean, incredible. This is just a conveyor belt of moisture. This is going to be such a moisture-loaded system that you won't really need an area of circulation that is powerful, because you usually need that during the winter time, but this is the first one of the season, and you can see just the amount of snow it will be bringing and the swath of it. That has been consistent with all the models, that it shows a giant swath of snow. And again, this one potentially extending over 2,000 kilometers, probably even 2,000 miles there. And the heavy snowfall rates, potentially some severe weather here, barbarically cold air behind this for this time of the year. And that is the monster system. And you can see, thankfully, this will be occurring after Thanksgiving, but it will be definitely interruptive towards the, I guess, the late Thanksgiving travel. People are returning back, but I guess better than occurring this week. And interestingly enough, as I mentioned with the AI model, there is the potential for this European model to slowly brew a second wave. Notice that this one shows it's kind of broken off completely from that system, while on the previous model I showed you, they almost looked connected. And that's the problem with some of the long-range models. It's hard to see what exactly is connected and not, because it's so broad and so averaged out, the view of the precipitation forecast. In this case, you could see it's a lot more defined, and it gives us a clear view of what may happen. This is just like one scenario. A lot less confidence with this system if it's going to happen at all, but it's something I've been noticing. And do note that it potentially brings snow again further east. Again, powerful rain and snow rates on either side of this wherever it occurs because of the moisture. And again, the cold air behind us will be nothing short of extraordinary. So now I want to show you the GFS model. This one's different. It's not from the European family, which the last two models I've been showing you have been. And let's start with this first system. So the one that's just going to be affecting potentially this upcoming week and into Wednesday and Thursday of, I guess, next week. It's Friday still, next week, Wednesday and Thursday. And do note what the GFS does differently is that it takes it and it merges these two pieces, the southern slug of moisture and that northern more circular, low pressure, it has a stronger circulation, more elegant, and it merges them a little earlier together, allowing it to become a little stronger and a little bit further west, not necessarily further south or north, but further west. You can see this affects North Dakota, southern Canada, there into Manitoba, Brandon, potentially even Winnipeg on the fringe right there, South Dakota, and into Minnesota with some very heavy snowfall. This would be actually very wind whipped, maybe even some localized blizzard conditions if this were to come true, but again, the details are still far out on that one. But it's definitely something to watch, and you can see that because it's further west and south, some of the cold air it may bring in might reach a little further south and east with this first cool down. But again, that's not the main story of today's video. That one is this thing right here. Not as much precipitation originally, but the GFS still develops it, and you can see it's moisture loaded. It has no support yet from any, I guess, direct precipitation flow into it, though it's picking up a lot of moisture from the Gulf of Mexico, mainly from the air that was originally from the Gulf of Mexico that found itself across the south, getting pumped into this system. And with the help of this high pressure, it also develops a massive swath of snow, not as impressive as a European, though still one that brings very heavy snow, potentially a foot and a half across a lot of these areas into Minnesota, Wisconsin, a lot of rain to the south of it. And interestingly enough, just like the European model, the GFS shows a potential separate system developing here, bringing snow very far south into Arizona, New Mexico, Texas, Colorado, and developing some sort of a separate system out of this. It looks very similar to the European model I just showed you, doesn't it? Yeah, so again, potentially two systems kind of birthed out of one massive cold front, and the cold air behind this will be cold. You may have been wondering why I haven't been showing you the snowfall amounts from any of those models I just showed you, and there's a few reasons for that. Despite the confidence quickly growing for a system, the snowfall amounts are still going to be very inaccurate. Not only because the system is far away, but we still don't know how the system will form. You can see there's differences from each model run. And I just want to show you now the ensemble. So this is a much healthier, I guess, view of what the snowfall may be. So this is the European ensemble. It's a family of 50 models combined. So this shows us snowfall through that December 4th, Thursday, 2025, so post this big system. And you can see it's not as defined as what one model would show you because this is many, many models combined, right? So some are showing it a little further south, some a little north. On average, though, you can see they're heavily targeting North Dakota, South Dakota, Minnesota, into portions of Canada, and the mountains. And I want to say something, that if you have a model that is so far out with the system, that has so many members, yet already showing amounts for potentially a large swath of Minnesota, South Dakota, North Dakota there, in the purples, which in this map's case means already 6 inches plus, and even those pinks starting to get a foot plus. So these amounts usually grow as it becomes more and more concise where that track will be. So this is a pretty interesting look at something that, again, could be indicating a monster winter storm. So now we're looking at the AI ensemble of the European model. So again, this is the first model I showed you, and you can see it's slightly different. It shows the heaviest concentration towards a little further east into Wisconsin, Minnesota. It's not as much targeting the Dakotas and into, northern Minnesota. Still targeting southeastern Canada. That seems to be the trend. So this one has a snow track a little further south. And here we have the GEFS ensemble. So it's that last model I showed you. It's from a different family. And you can see that its total snowfall outlook is pretty similar to the first one I showed you, the first European operational ensemble. And it really shows, again, heavy snow potentially already being averaged in at already 12 inches and above across North Dakota there. So incredible amounts for this far out that the ensembles are showing. Of course, those can decrease, but it is an interesting signal. And do note that it, again, keeps snow across southern Canada. It's a little further north than the AI one I showed you. Regarding the cold, I briefly want to mention this. I already know the video is probably long, so just very brief. I'll probably make a separate video about this sometime soon. The European AI model has been showing the strongest of the anomalies in terms of the cold. And at first I was like, this is probably incorrect. But then just like with the precipitation and just like with the systems that it's kind of picked up on a trend earlier than other models. The European operational one now agrees with this to an extent. It was at first in a camp of potentially not really showing much cold air. And if you look at the GFS, especially its most recent model runs of the operational one, it doesn't show much cold at all. So I am beginning to think that the AI model here is potentially a pretty darn good model. Who would have thought? The one that's AI enhanced is pretty good, and it may be a decently useful model for this upcoming winter. And yeah, the anomalies with this are absolutely incredible. If I were to show you the European, it shows cold in a very similar fashion, and at first it didn't, which is a concerning trend. And then if I show you the GFS, it's there, but it's just not as strong. So out of everything put together, I would lean towards more of the European scenario for the cold, and that has been the easier thing to track. So with that, I guess that makes sense that the system that the European models put out resemble more of what I think will be happening. I'll keep you guys updated. For now, that is it. Thank you so much for watching. I'll catch you all in the next episode. See ya. Bye.